Okay, so in this video, we're going to look at standard summations, or you might have heard me alternatively describe these as special sums. These are closed form things for when we're summing either the integers squared, or the integers cubed. So there's three results that you have to know. Two of them you get in your formula booklet, one of them you don't. So the first one is the sum of from r equals 1 to n of r, which is just the sum of the integers 1 plus 2 plus 3 all the way up to plus n, is equal to n plus 1 over 2. If you know your sum of arithmetic series, you could prove it that way, but you just want to be able to quote that, and you don't get that one in your formula booklet. The two that you do get in your formula booklet, but I would recommend you still know them off by heart anyway, because they're going to be useful, they're going to come up a lot, is the sum of r squared from r equals 1 to n, so this is 1 squared plus 2 squared plus 3 squared all the way up to n squared, can be written as n plus 1, 2n plus 1 all over 6. And the sum from r equals 1 to n of r cubed. Now this is just actually the square, surprisingly, of the sum of r. So this is n squared, n plus 1 squared over 4. So if you can remember the first one, you should be able to remember our last one just by squaring that result. The final one I'm going to mention, even though it's not really worth mentioning because you can work it out very quickly if you think about it, is just the sum from r equals 1 to n of 1. This feels a strange thing to write because we don't have an r involved at all. For if we sub in r equals 1, we're going to get 1. If we sub in r equals 2, we're going to get 1 still. So if we just do 1 plus 1 plus 1 n times, this is equal to n. Not something I think you should need to learn off by heart if you think about it, but it's worth just having in the back of your mind for when it comes up. Okay, so I want to do an example using these. So the first example I want to look at in terms of how we can put these into practice is what if we wanted to sum from r equals 1 to n of 2r plus 1 multiplied by 3r subtract 2. The first step we're going to have to do is just to expand these brackets and rewrite this. So this is going to be the sum from r equals 1 to n of 6r squared, 2r times 3r, and then if we expand the rest of the brackets, we're going to get, let's go on there, 6r squared, we're going to get subtract r and subtract 2. That's the summation we want to be doing here. Now, I'm going to put brackets around here just to make clear I'm summing all of that and that negative 2 is not outside this. So the key idea now is we can split this summation up into saying we want to do the sum from r equals 1 to n of, well, we want to do 6r squared, but I'm going to go another step and I'm going to write that 6 outside. That's going to be 6 lots times the sum of r squared. Subtract the sum from r equals 1 to n of r, and then I could write the sum from r equals 1 to n of 2, but I'm going to even take that 2 outside and say that's going to be 2 times the sum from r equals 1 to n of 1, because now we're just ready to sub in all the results we know. So we're going to have 6 times. Well, the sum from r equals 1 to n of r squared has an over 6 there, so we might as well simplify that straight away and say, well, it's 6 times that stuff over 6. So it's just going to be n plus 1, 2n plus 1. The second one, like I say, isn't going to be in your formula booklet. You absolutely need to know this off by heart. What is n plus 1 over 2. And then finally, we're doing subtract 2 times the sum of 1. Well, that's just subtract 2. And there. Now, if the question didn't say any more, then I suppose you could leave your answer in this form. In reality, most questions are likely to either ask you to leave it in fully factorized form or give you a show that. Because I haven't given you a show that here, I'm going to say let's work towards a fully factorized form for this. Now, it's very tempting to expand everything and then try and factorize. But if you expand everything here, you're going to end up with a cubic and it's going to be a little bit nasty to factorize. So look for any common factors first. In this case, we only have one common factor. There's an n that appears in every term. The other thing we can see, though, is we've got an over 2 in that middle term. That's annoying. Let's take that out and let's deal with everything else. So we're taking an n out because it's a common factor. We're taking the over 2 out to save us just having to make it all one fraction. So, well, what do we have to multiply n over 2 by to get this first term? Well, that, we're going to have to multiply it by 2, because we don't want it over 2. We're going to have to multiply it by n plus 1, and we're going to have to multiply it by 2n plus 1. looking at the second term, what do we need to multiply n over 2 by to get to that? We just need, we need a negative there, and then we need to multiply by n plus 1. Be careful to have that negative out, put those brackets and have that negative outside. That's one place you're really likely to make a mistake. And the final bit, what do we need to multiply n over 2 by to get to 2n? Well, we need to multiply by 4. Again, we've got a negative there, so let's put subtract 4 there. At this point, let's just deal with what we've got inside our big brackets here. I've done a big square brackets just so we don't have a bunch of brackets all looking the same. It's absolutely fine if you just do regular round brackets though. So when we expand here, well, what are we going to get? We're going to get, I'm going to do this expansion all at once. If you're in any doubt over expanding your brackets, just do this in 2 steps to avoid any mistakes creeping in there. Hopefully I won't make the mistake. So plus 6n and plus 2. And now, because we're being careful with our negative outside our brackets, it's going to be subtract n, subtract 1, subtract 4. And now we're just ready to go through and simplify what we've got here. So going through at this point, we've got 4n squared. We've got plus 6n minus n, which is plus 5n. And then we've got plus 2 minus 1 minus 4, which is going to give us minus 3. At this stage, it's really worth checking whether you can factorize that, because it could factorize further. In this case, there's nothing more we can do. So this is our fully factorized form. So using this, just as a reminder of what we've worked out here, this was the sum from r equals 1 to n of 2r plus 1, 3r minus 2. There's a couple of, if this was part A of a question, there's a couple of questions you could get as a part B of a question to follow this up. So one question you could get would be something like, well, what's the sum from r equals 1 to 2n of 2r plus 1, 3r minus 2? Rather than having to go through a whole bunch of work again, all we want to notice here is that all we've done is replace the n with 2n here. So in our answer on our other side, we should make sure we replace all our n's with 2n. So there's going to be 2n over 2, 4 times 2n all squared, plus 5 times 2n minus 3. Well, that doesn't have an n to worry about. And then let's go through and just be careful dealing with that. So that's just n. 2n all squared is 4n squared, so there's going to be 16n squared plus 10n minus 3. And I don't think that factorizes at least. Okay, so if you get a question like that, then you can use your previous answer and just replace your n's with 2n's in every part there. The other sort of question you could get would be to do something like, well, based on what you know, can you find the sum between r equals 10 and 20 of this thing? And the key step here is to notice that if we want a sum from r equals 10 to 20, well, we know we can find the sum from r equals 1 to 20 just by replacing n with 20 here. So we could, that bit's going to be fine. We're just going to be replacing n with 20 in our formula up there. But what do we want to get rid of? Well, hang on, this is doing 1, 2, 3, 4, all the way up to 20. But we only want to start our answer as 10. So we want to get rid of 1, 2, 3, 4, 5, up to 9. It's very tempting to do up to 10, but we only want to get rid of up to 9. So we're going to subtract from r equals 1 to 9 of that. And I'm not going to worry about subbing in at this point because you should be happy here. But all we're going to do is sub in n equals 20 into our original result, and then sub in n equals 9 to our original result, and do one, subtract the other. So main things to watch out for there are just going back. So firstly, make sure you know this result off by heart, absolutely. My advice is you know all these results off by heart. Even if you do have them in the formula booklet, it should save you, it's going to make you quicker. You're going to be able to practice a lot more easily. So expand, split up. I would always show this step where you split your summation. It'll make sure, even if you make a mistake later on, you're getting your method marks clearly. And as it is, even if you don't make a mistake later on, you're making clear to the examiner exactly what you're doing. And you're probably making your own life easier as well. And then the other thing to watch out for, don't immediately expand. Always look for what you can factorize out first. It will make your life, at the least, it will make your life easier. And the best, if you expand, sometimes you're going to end up with a quartic that there's just no way you're going to be able to spot how to refactorize. This will give you a way where you don't have to refactorize something huge in the first place. All right. Thank you very much.